Hi, I'm Garrett Town with AM Solar, and I'm going to be talking about the Victron BMV shunt-based battery monitor. So the BMV comes with a manual, a shunt which gathers the data, the monitor which interprets the data and processes everything and has an LCD display, a data cable to go between the monitor and the shunt, and power cables to take the measurements. So for this demonstration we have two 6-volt AGM batteries connected in series. This is the series cable that connects the positive of the most negative battery to the negative of the most positive battery. This is the positive connection point where you would connect the positives of all your loads, and off of the negative of the most negative battery we have a shunt cable that goes to the shunt, and this is the battery side of the shunt where that connects, and all loads would connect on the load side of the shunt right here. Don't connect anything here or to the negative of the battery. Everything connects on this shunt. And then in the COM port of the shunt we have a communication cable that goes to the meter, and then we also have one common configuration is the red power cable that supplies power to the whole unit that connects to this green port closest to the COM cable, and this goes all the way to the positive of the most positive battery. Another option might be to use this second red cable that comes with the BMV in this second port, and it can connect to any point along this series cable to get a midpoint voltage reading, or you can connect the other end of this to the starter battery positive and get a voltage measure of your starter battery. Another option would be to use the temperature sensor cable. You stick the red connector in the port closest to the black COM cable, and the blue end goes on the positive of the most positive battery. That way it still supplies power to the shunt and it gives you the temperature of the battery bank. Most people with lithium batteries choose the temperature sensor option because you can't charge lithium batteries when they're below freezing, and it's good to know how close your batteries are to freezing. People with vans and schoolies might benefit more from getting a reading of their starter battery voltage, which would mean using this second red cable with the connection right there on positive B2 on that green terminal block, and then this end going to the positive terminal of their starter battery. Another reason people might use the temperature sensor is if they can't install their charge controller next to their battery bank. The charge controller needs to pick up the temperature of the battery bank in order to provide an accurate charging algorithm. But if it can't be placed near the battery bank, then it can network over Bluetooth to the BMV-712 and get a reading of what the battery temperature is. The shunt is supposed to measure all current going in or out of the battery bank. In order to do this, we install the shunt between the most negative battery terminal and all other connections, including the chassis, inverter, solar charger, etc. For this demonstration I have two 6-volt batteries, which is a common configuration. This is the most negative battery, so the shunt is attached to it. With parallel 12-volt batteries it's a little easier because the negative is the same for both batteries. With our Victron lithium battery system, it is a little more complicated, but the concepts are the same. Just follow our wiring diagrams. This is not a time for artistic interpretation. Just do exactly how we have it drawn. One way you can visualize the function of a system like this is that electrical current flows from the positive terminal of the most positive battery through wires, through devices, through loads, all the way back through all kinds of branches, back down, and converges on the negative. In this case, the negative is going to be the load side of the shunt. That way all current in the system has to pass through this or it's not going to be measured. A lot of people ask me, well, I got my charge controller installed, do I just connect the positive onto the positive terminal of the battery and the negative onto the negative terminal of the battery? No, you don't do that. It will bypass the shunt. So you have to connect the negative onto here. That way it can flow through all the branches, converge at the shunt, and you can measure the current. And other people ask me, well, the instruction manual for the inverter says I need to connect the positive input to the positive battery and the negative to the negative. No, ignore that. The negative goes to here. This is the new negative of your system. Nothing connects here and nothing connects here. You want all the current to flow through the shunt. So all your negative connections have to take place here. That includes the charge controller, the inverter, the chassis connection, all negatives go through here. The only exception might be a specialized temperature sensor that would have to go on the negative terminal of a battery, but that's going to be very rare. Sometimes people get concerned because there's going to be a lot of connections on this one post. What we use to take care of that situation is we have a wire going from this post to another junction post so they can add more connections. Some indications that you may have done this incorrectly include the battery has a high voltage, which indicates a full charge, but the BMV says it's only at half charge. This means that at least one of your charging sources has bypassed the shunt. Check your wiring. Or the battery voltage is low, which indicated a low charge, but the BMV says it's at 100%. This means at least one of your loads is bypassing the shunt. Check your wiring. The shunt is a high current, low ohm resistor. This means that when current flows through it, the resistance will create a voltage differential between the two sides of the shunt. Recall the equation voltage equals current times resistance. Since the resistance is fixed, this voltage differential is proportional to the current. The meter measures this voltage, uses an algorithm to convert it into current, and uses program variables such as battery capacity, a Peucard exponent, the charge efficiency factor, etc. to calculate how much charge is remaining in your battery bank. The BMV is capable of showing net current. If current is flowing out of the batteries, it has a negative sign, and current flowing in would have a positive sign. Along with percentage charge, net wattage, voltage, amp hours away from full charge. Also, if you have the second red wire connected to your starter battery, it will show your starter battery voltage or a midpoint voltage. So for example, I just connected this system and it's showing a battery voltage of 12.65. That corresponds to roughly 50% charge, but if you scroll through the settings here, you can see that the BMV thinks it's at 100%. Once it reaches 100%, like an actual full charge, and your charge controller goes into float, then this will be accurate and any net current leaving the battery will count down from 100. In order to connect to the Bluetooth function of the BMV, you will need a smartphone like an iPhone or a Droid that can run the Victron Connect app. Download the app from iTunes or the Google Play Store. When you have the app, make sure your BMV is connected and powered up and your phone has Bluetooth enabled. Open the app and log into the device. When you first log in, you may be asked for a PIN number. This is 0 6 times, 000000. As you connect, the BMV may get a software update through your phone. This shouldn't take long. Once you are connected, you have a very friendly user interface that gives access to all the features of the monitor. AM Solar has created some custom recipes for different battery types that we commonly use. If you go to amsolar.com and click on the DIY Instructions tab, you will be taken to a page of our website where we keep all of our guides. Scroll down to the color chart that says Charger Monitor Setting Recommendations. On the section that says Victron BMV-712 and BMV-712, locate your battery type, flooded, Lifeline AGM, or Victron Lithium. If you have a different battery type not shown, send us an email and we will give you the correct parameters. Now, log into the BMV with your app. Click on the gear at the top right and set your parameters. When you're done programming your BMV-712, it's a good idea to change the pin from 6 zeros to something that only you know, because we sell a lot of Victron products and the odds of you camping next to somebody that's familiar with Victron and feels like playing around with your settings or changing your password are increasing every day. The way I like to use this system is I don't like to mount the meter on the wall. I like to put it down by the batteries because I don't want to see it. When I'm out camping, I don't want to pretend like I'm running a power station. A well-designed power system is going to take care of itself, and if you really need to know what's going on, you can connect to it with Bluetooth on your phone. Some common mistakes people make with this system in order of frequency are: number 1, incorrectly installing the shunt. Make sure nothing is bypassing the shunt. Check your wiring. Take pictures of the battery terminals and shunt and send them to AM Solar if you need interpretation. Number 2, incorrect programming. Double check your programming parameters and make sure that they match your battery chemistry. Number 3, it actually is working, but it's confusing you. It might be a good idea to watch this video again and let it sink in. Number 4, a product defect. I have yet to encounter this, but it is possible. AM Solar will help you figure it out. I hope this video was helpful. Happy camping.